Okay, so I think most of you were able to work on the front side, so I'm going to turn it over. If you don't have a graphing calculator, please go get one. We're going to start with these ones on the bottom of the back.
Can you drive me 16?
Okay. So this particular worksheet, yesterday we were given a table and we figured out how to find the y-intercept and the base number for your exponents, and we wrote equations. And then we turned our paper over and we were given pictures. And we practiced finding again the y-intercept and that change, that base. So how much is it changing by? Is it doubling each time? Is it tripling each time? Is it times 4 each? Is it getting smaller? So that's what we practice at the beginning of the class period. And then we give you this where you're given the exponential formula, and we're trying to see what does it look like when you plug in different values. But this is kind of a strange little piece of a graph. Normally they're squares. So if it looks funny, exponential growth, as you started to see on the front, it gets steep so fast, you would just be wasting space to have a big square-shaped graph. And exponential decay just dives on down. So again, we don't need a ton of space in either direction. Okay, I'm looking at number 10. Yours already has some numbers written in for your x values. So what we're going to do is we're going to plug all these values in for the exponent.
That's a 4x.
Look at number 10. On the back. Yeah, we're going to do the bottom three. So for those of you who weren't here, or for those of you who didn't finish it, we're going to do the bottom three together. And it was 3 to the power of x. So we type in 3, and then the caret, which gives us to the power of. And make sure you hit negative instead of subtraction sign. For graphing, you may want to leave it as a decimal. Like maybe 0.11 is easier for you to go up than a fraction. What did you guys do yesterday? Did we leave them as decimals or fractions? I like fractions, but some people don't. So if you want to turn to a fraction, you hit math, which is underneath your green button. So math, yes, we want it as a fraction, so you press enter twice. This is 1/9. So going back to my table, this is either 1/9, or you could have put in 0.11. It depends on which one you like better for graphing. Okay?
Would putting one borrow be acceptable?
Yes. Yeah. Okay, let's look at the next one. So this one is 3 to the power of -1. Like 3 repeating, or if you want it to be into a fraction form, it's 1/3. I like to do one with 0 in my head. Max, what is 3 to the power of 0?
3 to the power of 0?
Mm-hmm.
1.
And then I like to do this one in my head if I can. Dax, what is 3 to the power of 1? 0 to the power of...
Oh, I think 1 to
Sorry, 3 to the power of what?
3 to the power of 1. What?
What's 3 to the power of 1? Look how patient I was. I just wrote it down because I didn't wait very long.
I'm sorry.
That's okay. So another thing you can do instead of typing all of these into your calculator, we can find the pattern. Times 3, times 3, times 3. So please think about some of those shortcuts you can take. Be careful, right? Be careful that you don't actually pick the wrong factor. And with the fractions, it might be hard for some of us to know what it's doing. But once we get to those whole numbers, you can find the factor. Okay, graphing this. -2 of 0.1 is just almost on the line. -1 is 0.3. That's barely above it as well. And it's supposed to be like that. The one thing to mention is it will never cross the x-axis. It hovers just above it, and then will shoot up. The y-intercept is 0, 1, and then 1, 3, 2, 9, and I don't think we can go to 27. And I found that I'm horrible drawing these on my paper, but for some reason, they're half decent on the board. I cannot draw them on the paper. All right, let's try this next one. Go ahead and type, if you have not already, type in 1/2 times 4 to the power of -2. Let's see what we get.
Where you do 1/2 times 4 to the, and then the 4 is to the power of -2.
Yes, so make sure you put it all in at once, and your calculator will know to do the order of operations. It could be a decimal. What is it?
22 degrees.
Turn it into a fraction just so you can see. So you push math, enter, enter.
1/32.
1/32. Very, very small. 1/32. I don't know if you guys like the fractions better or the decimals. I don't. It depends on which way you can be more successful to graph it. All right, try the next one. Is it 1/16? What is the decimal though? Yeah.
Does it matter, that the 1/2 is like, on the paper, it was parentheses, like 1.5.
Over the what half? That's just another way to say multiplication. You could, so if you put parentheses around here in your calculator, it's just also telling you multiplication. So either way would give you the correct answer. So what are you guys getting for 1/2 times 4 to the power of -1?
I got
What is it as a decimal?
0.25.
So again, you just decide which way you like better when you're trying to graph it. Can you picture what 1/8 looks like? Can you picture what, I think the decimals maybe are easier to graph. Okay, I like to do this one in my head. What's 4 to the power of 0? 1. What's 1 times 1/2? And I like to try this one. 4 to the power of 1 is 4. What's half of 4? And maybe I can do this one too. 4 squared is? Nope. 16. And half of 16 is? And maybe I can see the pattern now. Times 4 times 4. I don't love typing them all into the calculator. I like to try to find the patterns in that. Okay, to graph it, -2, same kind of an idea. You're barely going above the x-axis. 0.031 is very small. That's like 3 cents when that's $1. This is like 13 cents. Like you're not even supposed to be to the 25 cents, so those are kind of hard. 0 should only be at half. Then it's going to start to swoop. 2, 6, 7. I felt like it was hard to see the lines on your copies. It's easier on the board. It's going to shoot up. 32 is not even on our giraffe graph. What is it like giraffes? Okay, is number 20 going to be exponential growth or exponential decay? How do you know? Oh, did you already do yours? How do you know? Yes, your base. So this is our exponent. This is our exponent here. We've got our base and our power. If the base is a fraction, it's going to go down very quickly. So you could say there was 2 germs on the, well, how would exponential decay be? Maybe something that's rotting, like in the rainforest or something, right? Something decaying very quickly. The power of 0 is 2. The power of 1, I think it's a half. Is this times 4? So you guys are getting? I don't know actually, is that an eighth or a fourth? I don't have my answer key, I'm holding Corbin's. An eighth and a third, 1 over 8, 1 over 32. So this is our first one that I'm showing, this exponential decay. So negative 232, I can't put it on there. Negative 1/8 is fine. The y-intercept is 2. 1 is a half, I can do that. And then they just are supposed to get so small so fast. I feel like most of you got pretty close to being done yesterday. Is that false? Raise your hand if you have a ton left of these. How many do you have?
Draw the graphs.
We just did these together. You didn't even do them.
Cody,
Cody,
This is a dumb.
you need this 5-minute power nap.
you just took it. Is this your stuff? We do have a lesson. I'm not giving you any more time to do this. This was your homework last night. Okay. We have some fun things to do today. We're going to be comparing linear functions and nonlinear functions.
Oh boy.
We'll be doing a card sort. So our notes are pretty short. If there is a lull and you need to finish your blue page, you can hop on it. So the notes page looks a little bit different than usual.
Did you actually fall asleep?
Ding, ding, ding. If anyone falls asleep, we should just all silently exit the room and then wake them up if the lights turn off.
Actually not. I don't think those things are funny at all. I think it's rude. Okay. So we know a lot about exponential functions and linear functions. We're just going to put it all on one spot. And this is your notes page, so please don't turn this in.
Wait, how do I do this?
I can show you this. Yeah. Yeah, you can have the basket. All right. Corbin, tell me some things you know about an exponential function. Nothing? I have your paper, you drew 20 of them yesterday. Okay. Sawyer, tell me something you know about an exponential function, which is what we've been doing the last 2 days.
Exponentially increases.
Oh yes, they go up so fast. Did you notice that with the numbers? Like, it went off the graph in 3 numbers. So fast. So let's write that down. Exponential numbers increase or decrease at a rapid rate. That's how I word it. And if you're not really sure what I'm talking about, look at that paper. The numbers go from 108 to 4/9. 4/9 is tiny. So think about pizza. This one went from 1/16. So picture a pizza, it's cut into 16 pieces, you get 1. And if it gets exponential, you get 64. It grows very rapidly. And if I went to the next one, it would be even bigger. So I think Sawyer kind of showed us with his arm what the graph looks like, right? So draw yourself, and it never goes over the x-axis, it doesn't go down here. So you can decide if you want to draw the growth, or you can draw one that's decay. I'm going to draw growth. Gabe, do you remember what the equation is for exponential functions?
Yeah, wasn't it like y equals a times b to the power of x?
That's exactly what it was. A times b to the power of x. Okay, so I'm going to tell you the situation, and we're going to write it down, and then we're going to make a table for it. So, or maybe I want to go the other way. Yeah, please fill in 0, 1, 2, 3. Actually, I want 4 also. And I'm going to start you out. I'm going to tell you that the y-intercept is 2, and then I go up to 6. So what's the pattern here? How do I find out the next few numbers? We are timesing. These are being multiplied or sometimes divided over and over, and this is to the power of 3. Power, or not to the power, the base is 3. 1854, and I wanted this one because 162 is super dramatic. What if this was like points in a football game? Your first touchdown is worth this. Your second one goes to here. Like, can you imagine how big points would get if sports gave you points on an exponential growth? And golf would be exponential decay. It would be like these tiny little numbers. Okay, here's a situation that this might represent. There are 2 bacteria on the railing. There are 2 bacteria on the railing, or on a railing, because that's our y-intercept. There's 2 bacteria on a railing, and what are they doing each hour? Tripling, 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 3 times. They triple each hour. Okay, try to write an equation for that. See if you can write an equation for that exponential table and situation.
Bottom of the situation, or like just
Wherever you have room. I had room above it on my paper.
Are they starting on hour 1 or is it starting on hour 0?
What is the y-intercept?
2.
So we have to find 2 numbers. We have to find our A and our B. The A is the y-intercept. What's the y-intercept on this one?
2 bacteria.
The 2. And then whatever the growth is your the base of your exponent. So what would the equation be? What would be the first number that I write?
A equals 2.
Like 2 numbers?
Yep. So maybe we should come back up here and remind ourselves. A is the y-intercept.
Well, so it would be y equals 2 times 0.
We just put 2. And then B is the base, or the rate of change.
So 3.
Why don't we just put 6x? Or 6 to the power of x. Yes, that completely changes our base. So looking at our exponents, we're actually multiplying by 3, multiplying by 3. So order of operations, please excuse my dear Aunt Sally, parentheses and then exponents. You want to do your exponent first and then double it. Do your exponent first and then double it. Somebody in first period was doing 2 times 3 and then typing, like then pushing enter and then saying like to the power of -2. They were getting really wrong answers. So the order of operations, your calculator will do it for you as long as you type it in right. Okay, can you guys find the number of bacteria after 7 hours? It might be huge. How many bacteria will be on this railing after 7 hours? This is not scientific, by the way. I made this up.
It's probably more
If you're germaphobes.
anything else. Because they multiply us.
Yeah, if you're germaphobe, it's actually much faster.
I know it.
We lost Isaac.
4,374.
1,374? 4,374? I didn't leave a very good space there. That's after 6?
So,
2 times 3 to the power of 7. 2 times 3 to the power of 7. Okay. It's okay to double check. Okay, let's go back and look at the linear one, which you've been doing since for sure 6th grade. Carter Wilkerson, what do you know about a linear function? We have slopes and y-intercepts. Do they look like this?
Why?
It's a little more consistent.
It's just kind of like,
Yes. Okay, so maybe draw what you think it looks like. Maybe you have a negative one though, right? You can draw a positive one, you can draw a negative one. Carter said it has a slope and a y-intercept. Y equals mx plus b. Maybe it's because I'm a math teacher, but I have a hard time doing the word part. I know how to do these ones. So you guys said it has a consistent increase. A lot of you are kind of showing me what it looks like. We've got a y-intercept and a, okay. So what I wrote up at linear, I wrote numbers increase or decrease at a constant rate. So this one's getting so much bigger. This one's being added or subtracted. So the numbers increase or decrease and we're doing adding or subtracting at a constant rate. This one was multiplying always, either multiplying by a whole number or multiplying by a fraction. So down at the bottom it says multiply or divide, but when we write our equation, we are always multiplying. Okay, let's look at the bottom. Right, they were good. Get the part over lost. All right, okay, the numbers I want you to put down here are 0, 1, 2, 3, and 8, 13. We'll start with that. 0, 1, 2, 3, and then 8 and 13. So be careful with this part. Carter Pitcher, how do I find my next number if this is going to be a straight line? I mean, like, how would I find this number? Can you? Yes, so it is this number.
Ooh.
Really?
Ooh. 5, sorry.
Yes, so instead of, like, if it was multiplication, it would be a really strange number, but 5 plus 5 plus 5. Okay, and the situation this might represent, John has $8 and earns $5 per lawn he mows. So he's very poor right now because you can't see anyone's grass. And it's gonna be a long time before we see that, really. Unless we have a heat wave. Right? Oh, can you imagine each lawn times 5? You have to be like to the millionaire by the 7th lawn. Do you see the difference in the wording? He, like Carter was saying, he doesn't earn 5 times more per lawn, although that would be phenomenal. Just 5 more. So words we're looking for here are like triple, double, a half, something like that. Okay. I'm going to pass out to everyone a baggie. Please don't mix them up with your neighbors. And they have either an equation, or a table, or a graph. Is that all the things? Equations, tables, and graphs. Equations, tables, and graphs. So, as you look at these equations, tables, and graphs, I think the graphs are going to be pretty obvious. If it's a straight line, it's linear. If it's a curved line, it's exponential. I think it's going to be pretty obvious with the equation. If it has a little tiny x, it's exponential. If it has an x like a variable, it's linear. But maybe the harder ones are these tables. So if my numbers get ginormous or very, very small, it's probably exponential. So once you have your pack, you're going to sort them into 3 categories. So here's what the paper says. After sorting the cards, write equations, tables, and graphs in the appropriate column. So let me show you. I'm looking at card number 6. This is card number 6. Linear or exponential? Okay, so I'm going to go on my paper. I'm going to go on my paper to where it says graphs, and I'm going to put a number 6 on exponential. So again, you're going to sort these out. Are they exponential, are they linear? And then if it's so this one is obviously exponential. It's not an equation. It's not a table. It's a graph. So I will put this number 6 in that space. So I will pass these out. When you get done with this, you need to come and get the homework paper. So this is a class activity. If you get them all right, then you can have the homework paper. It looks as good as mine. I can't draw them on paper either. On the board, apparently I can. Oh, I should have stopped my video. This is very exciting to listen to.
Bagel.
Yes, I'm going to have you turn this in.
Random noise.